Alright, so you just plug in the points of the vertex.
No, yes,
Like
no,
into
yes,
no, yes.
Thank you.
What did y'all?
Thank you. Thank you. All right, so let's talk about this one a little bit. So I saw some good observations. First things first, when we look at our responses here, value of h is positive or negative. Whenever you change the value of the h to either a positive or negative, you change its position on the y-axis. How else could we reword that?
On the graph.
So it is something to the y-axis. So to the left or to the right. Notice it's not changing just on the y-axis. And when you change the value of k to either a positive or negative, it's across, right, above or below the x-axis. Moving h moves the parabola left and right across the x-axis. Maybe not x-axis. Okay, so let's look at this idea, left and right versus up and down, right? And I see someone talking about shortening or widening the parabola near the vertex. I do want to show you this though, so I'll come back to those notes that some of us made. Notice if I change k to a positive, it doesn't actually make it skinnier or narrower. It's just I would have to zoom out or something, okay? So I want you to be careful of that. It's not quite doing that detail. What is h and k doing? First off, I will ask this. What's a direction that I could use for left versus right?
Negative, positive, nope, horizontal.
Say that again?
Horizontal.
Horizontal. There's a positive or negative number, but a direction for left versus right,
Horizontal.
that's horizontal. H, horizontally, by the way, what part of the graphic organizer should we be looking at for these notes? So we're still looking at vertex form. What's being affected?
The vertex.
The vertex. So where should we write notes?
Vertex.
Vertex. So H horizontally, and there's a word for this, translates
That's the word.
the graph, and I will emphasize not just the graph, specifically what's it connected to, the,
Vertex.
say that louder,
Vertex.
vertex, right? It's called vertex form, right? So it's translating the graph slash vertex. If h is greater than 0, meaning it is positive, the vertex is where? Where to the right, to the y-axis?
To the right of the.
Vertex is
Of the
to the right of y-axis. Just to save a little room, I would say if h is less than 0, to the left. Just trying to save a little bit of room, so we got a lot to write here. So what is k doing? What's the more mathematical term? Not moving. No, look at what I wrote. What's the more mathematical term than move? Translates. Now, so remember, horizontal versus vertical, J1, that's a direction. Okay? The mathematical term for move, in this case, is translate. So K vertically translates. The graph slash vertex. If k is greater than 0, then what? The
vertex is above the
y-axis.
when k is greater than 0, it's below the y-axis.
Chemistry.
Vertex is above. Notice positive, right? It's going to go up. And we're looking at the x-axis. It's above the x-axis. if k is less than 0, is below x-axis. We'll want to refer back to these kinds of notes to help us explore the next few, but we need to notice that h and k are affecting the overall the vertex. I don't know how that would look. Okay, so let's look at slide 6 together now. So I see a lot of common themes here, which is hard to see right there, but what coordinates, or what are the coordinates of the vertex? It seems that it is, what's the common theme that we keep seeing show up? The vertex is what?
One.
See, h equals x value of vertex, k is the y value of the vertex. I saw that show up the most throughout our responses. So when we look at this equation, a times x minus h squared plus k, from this equation, the vertex is, and notice how I say is, it's the same as, how would I put h and k together, you know, since the vertex is a point? H comma k. This definitely needs to go into the vertex form, right? H comma k is the vertex. Okay? So we want to have these notes in our book, but also we'll point out, you can always come back to this Desmos activity, explore this a little bit more, and remind yourself of these things. But the vertex is h comma k. Now, I want to point something out because this already came up with one student noticing and asking this question. Jaden was looking at, was it this equation? 1 times x plus 5 squared, was it minus 4?
The 5 was a 4.
The 5 was a 4 as well? Okay. So in this equation, what do you think your h value is?
4.
You think it's 4?
Yes.
Okay. So I believe what Jaden did was he came to, nope, that's not what I want. Here. And so you typed in, or you let h be 4, k be negative 4, and then you type that equation in, y equals 1 times x minus, no, plus 4 squared minus 4. Uh-oh.
Wait a minute.
Wait a minute. It's not quite a reflection. It's not it kind of looks like it could be a flip, but it's not that. Look again at this. It's a times x minus h squared minus 4.
Is it like just
What did I have to subtract so that it became a positive 4? Because notice what y'all are saying is that h is 4, right? So that would be x minus 4 squared minus 4. What did I have to subtract so that it became plus 4?
negative 4?
3.
If I subtract
Okay.
a negative 4, what happens when you subtract a negative? It turns into a positive. This is a detail that trips up students year after year after year. You need to pay attention to this. in order to get this plus 4, because it was x minus h, you had to subtract a negative. When it's x, say, minus 5, that is an h value of 5. But if it was x plus 2, h is a negative 2. You've got to notice that it's x minus h. So it's actually always the, what is this term when it goes from positive to negative?
Opposite.
It's the opposite,
Oh,
right? That's why that language is important, right? So with the h value, it's always the opposite. Is it the opposite with the k value?
No.
No, because you're adding, right? So you don't have to worry about that detail. Notice if I make h a negative 4, it matches. And Jaden and everyone else, I want you to notice, it looks like a reflection, but notice right here, remember how when we change h, it translates? So it wasn't a reflection, it was a translation. Okay? So that's what we want to notice.
What do I see?
Alright, last detail here. I know at least one group, group 4, came up with an equation for the axis of symmetry. Did anybody else come up with the equation for the axis of symmetry? So this is slide 7.
No, sir.
No?
I was working on it.
We were working on it? Alright, so group 4, talk us through what you did for the axis of symmetry. Group 4?
Yeah, that's y'all.
What equation did y'all come up with? Alright, let me ask you this. First off, what did the equation start off with?
Y equals, it started with the vertex one.
So y equals,
A.
no, just like the equation for the axis of symmetry. Right, so I'm looking at this. Right, we're still looking at this slide 4. I'm talking about what equation did you type in for the axis of symmetry?
We put
X equals
put h equals x. Yeah,
You said x equals, right?
yeah. Or h equals x.
Or, okay, so x equals h? Or h equals x. So I want you to notice, first off, if I type in x equals h, does it give me the axis of symmetry?
No.
Does it create symmetry around that line? Yeah? Okay. Let's change h to a 5. Does it still give me an axis of symmetry?
Yeah.
Notice how it's not just, hey, x equals blank, or a number. They used a very generic x equals h. And they did that originally by testing out some numbers. But x equals h, where h is from the vertex form, right? Does that give me the axis of symmetry?
Yeah.
Yes. And so, where would I write this equation? Under axis of symmetry, right? We would want to type right there, hey, x is equal to h. That is the axis of symmetry out of that vertex form. Every single time. And we see that it works, no matter what the h is.
Just wanted to let you know that the girls' basketball team tomorrow will be playing during 4th period against Tuscaloosa County High. Coach Perano and Coach Armstrong will be selling tickets today and tomorrow for $5 during lunch. So they want you to try to buy your tickets and come and support our girls' basketball team tomorrow during 4th period, and the tickets are $5.
Really quickly, actually, before I show this, I do want you to see what we're going to be starting with tomorrow. We definitely got some more work to do. But this is where we're going to start. You've typed out and written out these notes to yourself. Well, here's 4 different vertex forms. Using your notes from the graphic organizer, you need to identify what the vertex would be out of those equations. You need to identify the line of symmetry, or that's also called the line of symmetry? Okay, well, I love the effort, but axis of symmetry, right?
Yeah.
Okay, and then the concavity of the parabola. We want to pay attention to those things. And then we're going to look at the other 3 forms. You got to come in ready for that understanding check tomorrow. So look, a lot of us are about to get some lower unfortunate grades for our homework. You got to get those missing homework grades in. Look to look to Power Schools to know what you're missing. The graphic organizer, listen, I reduced the concepts that are due tomorrow. You only have to go from exponential functions through parabola. That is the front, you have to finish the front page of that blue graphic organizer. And those are due tomorrow. I have added in some Mathia to help us get practice with quadratic functions. Observing patterns is due Friday, February 4th. Right? This forms of quadratic functions due Tuesday, February 8th. I want to pause for a second because Jaquan did bring this up earlier. You don't have to have 100% in Mathia. Mathia has every workspace that you will have the entire semester. You have to have 100% of the workspaces for equations done. There was supposed to be a total of 5 of those, right? There was 4 in the out of 7, and then there was the 1 quadratics one. And then you need to have all of these done by Friday and by Tuesday. Make sure you pay attention to it because it's only parts of the different units or modules that we have. So make sure you're paying attention to that. Sound good? All right. Make sure we're logged out of our computers. Yes, sir. I will have to print it out. Wait, Jake, come here.
What do you see?
Want to take a picture and put it on the plastic screen? Let's get it. Come on, you want But
I'm never gonna do that. The way you tapped him in my throat.
Come on, Jake.
Don't let it happen again.
Well, I'm gonna tell everyone, like, Jake didn't want to be pictured, but this is who we're celebrating, all right? I gave him back on Friday, yeah. Nice, William. Any blue ones in here? Are you sure you gave me the blue one? I'm sure. Check your backpack real quick. I'm just saying. I don't see it. Well, you should have 2 pages for the graphic organizer, and you would have only given me one in the first place. I don't remember what day I gave them out, but it looks like this. You never got one of those? That would be it then. So first off, like I did give back. So I gave. First off, you did have this one, right? And then you resubmit. Did you resubmit for those last Tuesday? Mathematical representations to verbal and contextual. Okay. So I would have that still. I haven't given feedback on those. Let me print out. I'm here, boy. Alright, so printing this out for you. Yes. Last week, data through linear models was due. That's based on the lessons on understanding concepts of linear functions and understanding data in context. We did a lot on the calculators. Look back at those. So those are already due, and then just due tomorrow. Yes, sir. So I'm we got like 25 minutes. I'm hungry. No. Here. No. Did you shave? No. Get more cleaned up? You did get a haircut. Okay. Like, I noticed some things.
I was looking on nothing. I appreciate it.
Oh, damn. Just in case I don't look. They're good at it. How's it going, man? What about you? You been?
How was your weekend? Yeah?
People got so fast.
Nice thing is, my week's about to go by fast because teaching today and tomorrow.
Yeah, no good, man. My shit go too.
Thursday and Friday, my insurance teaching. Right? I'm gonna be so caught up on things. This is, I will say this, I didn't get any He and I will test together.
I was about to say,
That took us 6 hours just to build one. Because like what we did is we built, that's a box with shelving, that's.
Fur, late. Oh, fur. Late, dude.
And put in the set, that right there.
Kill goldfish, show them how that pole hit.
But it was 6 hours just this weekend, we'd already worked on it. I was off, I did nothing else Saturday. That's what I want, and that was the Christmas present for my wife. Technically, Christmas present for her. Sometime last year, she was pulling something off of.
What you was in? Like, you keep saying you gonna
man,
pull up, but you never pull up.
I'm
That's a little better.
We was all, I don't know, bro, that ain't no excuse. That ain't no excuse, bro. You never pull up.
Each piece of plywood that we had built in there, like 8 of them. There's 7 of them. Oh, yeah.
Oh, no, my birthday was 12, 16.
Did you
Let me get C9, this year.
Did
you tell me you were leaving?
Bars, like,
I will not leave. Mom
You will?
makes me big legs, and you have some of the, all that kind of shit.
oh, you were born.
Well, you gotta learn some stuff.
Thanks, Lynn.
It's a little funny.
I don't know.
We got stuff to learn. Isn't that like the